Hi, my name is Jamie Ruiz and I'm doing my presentation on the effects of cocaine. I decided to do my presentation on the effects of cocaine because a lot of my old friends have started using the highly addictive drug, and I'm curious as to what makes it so addictive. This falls under the biology of affect, cognition, and behavior. Cocaine is a bitter, crystalline alkaloid obtained from cocoa leaves that is used in the form of its hydrochloride. The makeup of cocaine causes a short but extremely intense high, and then following after is an intense depression, edginess, and a craving for more of the drug. There are many different side effects when using cocaine, like not eating, poor sleep, increased heart rate, muscle spasms, anxious or hostile behavior, and many more. A person can consume cocaine two different ways, by either snorting the powdered form or when it's processed to the form of freebase, it can be smoked. Smoking gets the drug to the brain more quickly than does snorting. Snorting requires that the cocaine travels from the blood vessels into the nose to the heart, where it gets pumped to the lungs to be oxygenated. The oxygenated blood carrying the cocaine then travels back to the heart, where it is pumped out to the organs of the body, including the brain. However, smoking bypasses much of this. The cocaine goes from the lungs directly to the heart and up to the brain. When someone smokes cocaine, it reaches all of the areas of the brain, but specifically binds to the VTA, the nucleus, accumbens, and caudate nucleus. The binding of cocaine in caudate nucleus, for example, is the reason as to what causes people to pace, nail bite, scratch, etc. Like I said before, cocaine binds to areas in the brain that are rich in dopamine synapses, such as the VTA and the nucleus accumbens. Dopamine is released into the synaptic space. It then binds to dopamine receptors and then is taken up by uptake pumps back into the terminal. This photo gives a clear visual of what happens when cocaine is present. It binds to uptake and prevents them from transporting dopamine back into the neuron terminal. So more dopamine builds up in the synaptic space and it is free to activate more dopamine receptors. Agonists mimic and antagonists block. When cocaine is in a person's system, it sits on the dopamine receptor and does nothing. It is blocking the way for dopamine to pass through. Because some dopamine isn't allowed to pass through, the body will eventually begin to stop making it, and this is the reason why people get withdrawals. A person having withdrawals would feel depressed, exhaustion, unpleasant nightmares, anxiety, etc., and end up having a craving for more of the drug to feel better. A cycle of addiction is then born. When a person has no cocaine in their system, the correct amount of dopamine is produced and able to pass through. A good balance between feeling overly happy and deeply depressed is because of dopamine. As a result of cocaine's actions to the nucleus accumbens, there are increased impulses leaving the nucleus accumbens to activate the reward system. This pathway can be activated even in the absence of cocaine. For example, during the craving, the body relies on this drug to maintain rewarding feelings. They are no longer able to feel joy or happiness without cocaine. So the user becomes dependent, and when there is no more cocaine, the inability to feel pleasure becomes relevant and depression occurs. To avoid these feelings, users go back for another dose of cocaine. Cocaine addiction and dependence both involve structures in the reward pathway. Now, fun question. So what does cocaine molecules do once in a person's system? A, sits on the dopamine receptors but still sends a signal. B, passes through the receptors and does nothing. C, blocks the dopamine receptors. Or D, goes nowhere near the receptors. The answer is C, blocks the dopamine receptors. The research I found was from an article called The Neurobiology of Cocaine Addiction. This site can be trusted because it was from the U.S. National Library of Medicine and National Institute of Health by Eric S. Nessel, MD, and PhD. The other article I found that was trustworthy was off of the Science Daily with a source from Carolyn Smith posted on September 12, 2018, which was fairly recent. After listening to my power presentation, it is my hope that you have gained a better understanding as to how the addictive aspects of cocaine have a lasting effect on the human body. Thank you for watching.